Hi guys, I hope you're doing absolutely fine. Welcome to the next video in the machine learning playlist. Today we're going to start simple linear regression. Let's understand the terminology of simple linear regression. First of all, we have regression. Now to understand regression, consider this equation y equals to some coefficient a x1 plus b x2. Now regression simply means correlating these independent variables with a dependent variable. It means we are somehow connecting these independent variables with a dependent variable with the help of these coefficients. In simple terms, when we start solving a problem, you will get to know that we will have an equation like this: a equals to some coefficient theta naught x naught plus theta 1 x1, and our problem would be to find out theta naught and theta 1. Then we move on to linear, which means that any equation that we find out in our problem will be a linear equation. It will not have polynomial terms. And simply means we will have only one independent variable. In this case, we will only take say theta naught and x naught. So we can give this form to the equation, which will be later defined as simple linear regression. Now to understand this, we will take a problem statement. The problem statement is we have to predict the house price given the number of rooms. Example में हमें number of rooms दिया गया है and the price of the house depending on the number of rooms. This is a very simple problem statement. So here we are predicting the house price. So the dependent variable would be the house price, which is y, and the independent variable, which is x naught, will be the number of rooms. This will be x naught. Let's take some random examples. Let's say the number of rooms is 1, 2, and so on. Let's take the price as now. You can see from your common intelligence, you can see that the correlation that we have formed, the equation that we have formed in our mind is y equals to 2x, as simple as that. But given this data, how will a computer understand? How will a computer get to this equation? Now, making a computer solve this problem and reach to this equation is the problem of machine learning. It is the problem of simple linear regression. So to get there, we will define some terminology which we will get to in the next video. So now that we know our problem statement, हमारा problem statement ये था कि given the number of rooms, we have to find out the house price. So now that we know our problem statement, let's figure out how to teach a computer to do that. And we'll do that using simple linear regression. Let's plot these points first and see what we can make of it. So for one room we have 1, 2, that's 1, 2. For two rooms we have 0.4, 1, 4. For 3 we have 6. And for 4 we have somewhere around here, let's say 4, 8. Okay, and this is the equation for y equals to 2x. This equation, ये तो हमने देख के जान लिया कि y equals to 2x हो रहा है, but how do you teach a computer to do that? so that अगर मैं पूछूं कि किसी घर का 5 रूम्स है तो उसका प्राइस क्या होगा, तो the computer can fit in this line and say that the price of a house having 5 rooms is 10 into 10 to the power 6. So for simple linear regression, we have a couple of steps that I'm going to tell you now. पहला step है, we are creating a hypothesis. We create a hypothesis that h equals to some theta 0 plus x theta 1. H is the hypothesis, x is the independent variable, and theta naught and theta 1 are the constant coefficients. So, first of all, we need to randomly initialize these coefficients. Now, our job is to modify these coefficients so that this equation can fit all of these data points. Now, if you did not know before, this is our training data. This is our training data. So first we need a hypothesis, and we need to randomly initialize these coefficients. To make things simpler, I'm going to initialize them as x equals to, let's take theta 0 equals to 0 and theta 1 equals to 1. So h equals to x. Plotting h equals to x, we get something like this. Which is obviously not the correct line to fit all of these points. So we have to now modify these theta naught and theta 1 so that this line can slowly get inclined with this line. Theta 0 and theta 1 need to be modified so that this line can fit all of these data points. Okay, so our next step will be the cost function. It is also called error function. Now, in case of simple linear regression, the error function that we will use is called, let me just write out the function for you. As you might have recognized, this is also called the mean squared loss, because we are actually squaring the Euclidean distance in taking its mean. So it's called a mean squared loss. Why are we taking this kind of error function? Look at this graph now. The plot that we need is this, but the plot we have now is this one, y equals to x. How do we get from here to there? So first we need to calculate the error between the points. and then we need to modify the hypothesis. So in order to calculate the error from this point to this point, or from this point to this point, for a linear 2D graph like this, we are taking the Euclidean distance. And that is why we have an error function like this. So let's go through today's topics. Let's go through today's points and see what we can make of it. So first we have a hypothesis. A hypothesis x equals to and an error function, which is a function of theta naught and theta 1. The n here represents the number of examples. So this is xi, x2, x3, x4. So in this case, m will be 4 and I will be the example number. I hope you got to understand what hypothesis function is and what error function is. This is all for this video. In the next video, we will move on to gradient descent. Gradient descent is a way to use this error function to modify the hypothesis function so that the hypothesis can fit these data points.